So in this video we're going to do some mechanics skills, working with vectors and a popular type of question that comes up that lots of people are not too sure about. So we've got a particle moving, and we've got an equation here about the acceleration, okay, in terms of I and J. So something we talked about in some previous videos is notice that they have t in them, so the acceleration changes. So this is variable acceleration, which means that we want to be using skills typically where we're like differentiating and integrating. Okay, so calculus. So not SUVAT. At t equals 0, we've got some information about its position and its velocity. Pardon me. So first question is pretty run-of-the-mill. So find the velocity at time t seconds. So it wants a general sort of formula about its velocity. So how are we going to do that? We're going to integrate acceleration with respect to time. So we are going to, let's do it up here. We're going to integrate, let's write it as 2 minus 6t and 4t squared minus 4t with respect to t, which is going to give me 2t minus 3t squared plus a c. Hang on a moment, we've just integrated, so we don't need that one anymore. Let's do it like that. And the other one is going to be 4 over 3t cubed minus 2t squared plus its c value. Okay, and how do we find these c values? Well, that's actually what this piece of information over here was all about. Okay, so it's saying that when t equals 0, this is what the answer is. So effectively, if you put in t equals 0, it was velocity, sorry, wasn't it? It was velocity, so it's this bit over here. So it's 6 minus 4, yeah? It's 6 minus 4 when you have 0 in all of these things. So a lot of these are going to be just 0. So can you see that C1, for example, is going to become 6? Let's do the minus 4. Well, the minus 4, the same thing's going to happen, okay? So when you put 0 in on those there, you're going to get C1 is 6 and C2 is minus 4. So let's just kind of write this nice and neatly now. So I'm going to say that it's the velocity equals 2t minus 3t squared plus 6. That was the c value that we just found. So it's that I plus the j bit is going to be 4/3 t cubed minus 2t squared minus 4. That's going to be the j part. So that's pretty standard, the first part. So the bit that we're a bit more interested in is how we would answer a question like follows. So find the position vector. So this we would integrate when the acceleration, okay, so when the acceleration is parallel to this bit here. So I want to focus on how we answer this part in particular. So we're going to get rid of that bit over there. And we can start in two different places. So find the position vector. A lot of you would have realized already that, well, to get the position vector, that's about displacement. So we want to integrate velocity, which is true. That's kind of part of the puzzle. But how about when the acceleration is parallel? Because I think that's the bit that's really sort of less obvious. So the acceleration, well, we know what the acceleration is already. So the acceleration generally is given by 2 minus 6t and 4t squared minus 4t. So how do we read statements like is parallel? Well, is for me means an equal sign. Parallel means is going to be some multiple or some factor. So I'm going to represent that as lambda. 2 minus 2 minus 2. So that's the way that I'm going to write it. So generally, if somebody says to me something is parallel to, Well, the is the equals, the parallel is the lambda bit, and then this is what it's parallel to. If they had said that it is the same as, I wouldn't have put that lambda there. But because they said it's parallel, I'll put that one in front. And then what will I do next? Well, I will sort of use these equations simultaneously. So I would do this. And here, do you see that they actually are both kind of the same? So you can sort of use this to solve for a t value by doing something like this. But it won't always be quite as neat as that. It won't always work out quite so nice. But I get 4t squared plus 2t minus 2 equals 0. And eventually this leads me to an answer of t equals a half. There is a negative answer as well, but because it's time, contextually, we'd have to do that. So the way we'd finish off this question now then is we'll integrate one more time and then we'll just use t equals a half. Okay, but that idea of is parallel to, or sometimes they do slightly different things to this. Sometimes they say like it's traveling northeast or east or something, and you can do similar sorts of things by thinking about the I and the J components to help you find a time. So I think we'll sort of just zoom ahead to the solution for the final part, all right? But what we would do is we'd take that answer from before, we'd integrate it with respect to t. Notice because we're integrating again, we will have to use this additional piece of information to help us find out what our c values are. There'll be a c value for the I and the j part. So let's take a look. So here we go. Our final velocity we kind of had before, and we've got our t equals a half. So the final idea really is we'd just be integrating these parts here. And eventually, if you do that, you'll get that the new c values are both 2, a little bit like on the question before. And you plug in for your I and your j and get your position vector that way. So let's give you a chance to practice it one more time. So I'd encourage you to pause the video and take some time to go through this question here. And let's have a go at it then. So we've got our acceleration. We've got, again, our piece of information for the integration. And we're looking for the time when the acceleration is parallel to this. So let's do the parallel part first. So we've got 4t minus 3, t squared minus 2t. And we're going to say that this is parallel to 1. So that would give us 4t minus 3 equals 2 lambda, and t squared minus 2t equals lambda. You could double the denominator to get the j equation. 2t squared minus 4t equals 2 lambda. And then you could use these equations together. So let's do that. So 4t minus 3 equals 2t squared minus 4t. That's the same as 2t squared minus 8t plus 3 being equal to 0. And from that one there, this one doesn't give you such a nice t value. The t value on this one in surd form seems to be 4 plus root 10 over 2. So now we've got our t value. What would we do with the other part? Well, with the other part, we're going to integrate again. So let's do that. Let's integrate 4t minus 3 and t squared minus 2t, which is going to give us 2t squared minus 3t plus c value. And over here, this is going to be 1/3 t cubed minus t squared plus its c value. We've got to read this piece of information carefully. At time 0, velocity is 2 minus 1. So yeah, by inspection there we can just say, because everything else is a t value, so as a 0 it would disappear. So what was that? 2 and minus 1. And then we can integrate those values. So let's integrate now 2t squared minus 3t plus 2 and 1/3 t cubed minus t squared minus 1, which would take me to 2/3 t cubed minus 3 over 2t squared plus, plus 2t plus 2t plus 2. No, sorry, that's plus a c value. I'll call it c3. And this one over here is going to give me a 12th t to the 4 minus 1/3 t cubed minus t plus another c value. Do we do the same thing here? Yes, at time 0, it's a 1 and a 3. So we could just put those numbers in there straight away. A 1 and a 3. Okay, and what's the actual question? So find the position vector. Right, perfect. So all we would do now to finish off with in this situation is we would just plug our t in there and we would have our final answer. Okay, so if you do get situations where you are told that it's parallel to another vector, my suggestion would be to write your vector is parallel the other vector, and then to kind of make it into two equations and go from there.